Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 in KSP5. We will present about Halu Alkin in Chapter 7. Our team member have 5 members. First one is Nik Nor Najihah binti Abdul Rahim. Second is Nurul Bazilah binti Aminuddin. Third is Busyra binti Abdul Alim. Fourth is Nur Dina Mariha binti Mat Sidin. And lastly, Farah Hakimah binti Fauzi.
So for Quranic verse in this lecture, I will say in the Al-Quran, in the chapter Al-Ma'idah verses 96. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم أحل لكم صيد البحر وطعامه متاعا لكم وللسيارة. It is lawful for you to hunt and eat seafood as a provision for you and for travelers. Surah Al-Ma'idah verses 96. As for the inner component, traditional group represented is Halal King, and we choose seaweed as a plant that related to this topic. And then the related Quranic verse is Surah Al-Ma'idah verses 96. One of the components in seaweed is metal iodide, which is one of the halal king. It was produced by microbial cultures derived from decaying cat tissue. It is a product of both cat and microbial metabolism. The metal iodide contains the haloalkane functional group, which is a derivative of alkane containing one or more halogen. The structure is shown below. So here is the structure. Composition of the plant: 1 cup or 80 grams of raw kame seaweed contain 36 calories, 0.5 gram fat, 698 milligrams sodium, 7.3 gram carbohydrate, 0.4 gram fibers, 0.5 gram sugars, and 2.4 gram protein. As we all know, seaweed has many benefits, so I list down a few benefits of seaweed here. So seaweed is rich with vitamins and minerals, including potassium, which is an important component of heart healthy diet since it can help lower blood pressure. Not only that, seaweed is also known for having high antioxidant compound. This is contained in pocoidin, which are shown to prevent bone breakdown by free radical and indirectly reduce the risk of osteoporosis.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Dina Mariha binti Mat Sidin and my matric number is 9200235. Question 5 states that haloalkane with molecular formula C4H9Cl has 4 structural isomers A, B, C and D. The structure of A, B and C are shown below. Give the IUPAC names and classification for isomers A, B and C respectively. For the classification, when the structure has 3CH3, we classify it as tertiary carbon. If the structure has 1CH3, we classify it as primary carbon. And if the structure has 2CH3, so it is a secondary carbon. That's all from me. Thank you.
My name is Nik Nor Najihah binti Abdul Rahim and my matrix number is 9200205. Okay, so the next question is arrange isomers A, B and C in ascending order of their reactivity with respect to SN1 reaction. Explain your answer. Okay, so the answer is isomer B is less reactive than isomer C and isomer C is less reactive than isomer A. So isomer A is the most reactive. This is the structural formula of isomer A. We can see that there is 3 alkyl group and a halogen attached to the carbon. So why the structural formula affect the reactivity? In SN1 mechanism, a tertiary haloalkane is more reactive than a secondary haloalkane and primary haloalkane. Why? This is because the rate of reaction will be governed by the stability of the carbocation form. The more stable the carbocation form, the more reactive the compound will be. Okay. So, as we know, the stability of the carbocation depends on the number of alkyl group attached to the carbon. So, the more alkyl group attached to the carbon, the more stable the carbocation. Okay, in addition, alkyl iodide is the most reactive of the functional group, which is haloalkane, because the bond between the carbon and the halogen is the easiest one to be broken down.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Bazilah binti Aminuddin. My metric number is 9200210. I will present about reaction equation involved for the reaction of the most reactive isomer with respect to SN1 reaction with aqueous potassium cyanide in ethanol under reflux. In previous video, we know that most reactive compound is compound A. Compound A is 2-chloro-2-methylpropane and tertiary carbon. Next, the mechanism of SN1 involves 2 steps. Step 1 is formation of carbocation, and step 2 is nucleophilic attack on carbocation. Next is the mechanism of reaction. Step 1 is formation of carbocation. We know that this is compound A, 2-chloro-2-methylpropane, and this carbon is delta positive and this chlorine is delta negative. This single bond consists 2 electrons. Both of the electrons will go to the chlorine. So we will get a carbocation and anion of chlorine. The first step is slow reaction. Next step is step 2, nucleophilic attack on carbocation. Nucleophilic for potassium cyanide is Cn-. Cn- will attack at the carbocation. So with the fast reaction, so we will get 2-cyano-2-methylpropane.
Assalamualaikum warahmatullahi wabarakatuh. My name is Busyra binti Abdul Rahim. My metric number is 9200202. Now, I will explain the next question. My answer for isomer D is 1-chloro-2-methylpropane. Next, I simplify the question into this structure. The question asks, isomer D reacts with magnesium in anhydrous ether producing an alkyl magnesium chloride, structure E, which is then hydrolyzed and produce structure F. Structure E, my answer is 2-methyl-1-propyl magnesium chloride. Structure F, my answer is 2-methylpropane. Then, the elimination of D with ethanolic KOH under reflux produces structure G, which is 2-methylpropane. Then, the treatment of structure D with sodium metal in ether solvent yields a symmetric alkane H, which possesses 2 tertiary carbons, and I get 2,5-dimethylhexane. Lastly, hydrolysis of D with aqueous sodium hydroxide solution under reflux produce alcohol I, which is I get 2-methylpropanol. From that, we get the answer structure E, 2-methyl, 1-propyl magnesium chloride, structure F, 2-methyl propane, structure G, 2-methyl propene, structure H, 2,5-dimethyl hexane, structure I, 2-methyl propanol. That's all from us. Thank you.